On July 24th, 2019, Elon Musk announced a big change to the Tesla management team.
Important update, JB Straubel, co-founder and chief technology officer, will be transitioning to a senior advisor from the CTO role.
This was a pretty dramatic moment. After all, JB had worked alongside Elon for 15 years and helped transform Tesla from a tiny startup into a massive public company. So why would JB call it quits at Tesla after so many great years working with Elon? JB had realized something really important, and he had to act immediately. He had seen electric vehicles become a reality firsthand, and could tell that the industry was going to be massive. These new EVs would help curb carbon emissions, but they created a new problem: e-waste.
The staggering amount of the world's e-waste is ending up being burnt in open dumps in impoverished Ghana.
Recycling old lithium-ion batteries is incredibly difficult, and without a solid program to deal with them, e-waste will just start piling up. This wasn't just an opportunity to help keep the environment clean, though. It could also be a huge business. So JB left Tesla to start a new company called Redwood Materials. This story gets less attention than your average Elon Musk tweet, but it's incredibly important. So let's dive into the used battery problem and how JB is planning to solve it. Lithium, nickel, cobalt, and graphite are all key components in lithium-ion batteries, but mining them can be incredibly damaging to the environment. Extracting just 1 ton of lithium from the Andes Mountains requires 500,000 gallons of water. Mining nickel in Russia has lowered the life expectancy of the local residents by 10 years. And 60% of the global cobalt supply comes from the Democratic Republic of Congo, where manual laborers work in dangerous mines without safety equipment. It's all incredibly difficult. So it's absolutely critical that when we extract a particular resource from the earth, we don't let it go to waste. Pollution is a huge issue, and it doesn't end with mining. After raw materials are extracted from the earth, they need to travel to a refinery, which is often in another country. And once they actually are refined, transforming these resources into something that can actually be used in a battery requires another trip across the globe to a different factory. The entire process, from mining to final battery pack assembly, can often incur tons of carbon emissions, since the supply chain spans the entire world. These batteries also don't last forever. Even though many EV batteries can now last for hundreds of thousands of miles before failing, we will still need to recycle millions of battery packs in a few decades. We simply don't have enough recycling capacity to handle the wave of dead lithium-ion batteries that is coming once today's EV owners start scrapping their cars. Currently, only 5% of all lithium-ion batteries wind up getting recycled. Fortunately, JB Straubel saw this problem coming and is working on a solution. But before looking at his plan for Redwood Materials and a full sustainable battery, we have to examine what makes him uniquely qualified to tackle these challenges. JB's interest in electric vehicles developed back in the 1980s, well before most people even knew that EVs were a real possibility. At age 13, he rebuilt an old electric golf cart, which taught him how batteries and electric motors worked.
It was kind of a souped-up electric golf cart that was a whole lot of fun.
Did it work?
It worked well. It was maybe a little too dangerous.
Many successful entrepreneurs have stories like this. When Elon Musk was 12 years old, he programmed a video game and sold it to a magazine for $500. And Bill Gates landed a contract to build software for a water utility when he was just a teenager. Working on a hobby project with a tangible outcome is a great way to learn important skills. The earlier you start building, the more time you'll have to let these skills compound on one another. JB's builder mindset led him to Stanford in 1992. He was already interested in electric vehicles, but there weren't really any degrees that fit his interests, so he wound up building his own curriculum. He studied physics and chemistry to get a handle on how the batteries would work in an electric vehicle, and then he took courses in computer science to understand how to control the electric motors.
I actually defined my own major and ended up defining a major called Energy Systems Engineering.
Are you the only person in the history of the world who's done it?
Well, I think at this point, they actually have a whole track, focused on energy. I'm pretty jealous.
Yeah.
When I was there wasn't too much to do.
He wasn't only focused on class, though. While working on his bachelor's degree, JB also worked at Rosen Motors, a company designing a new hybrid powertrain. The system was ahead of its time, but the big car companies weren't interested in rethinking their car designs, so Rosen had to shut down in 1997. JB graduated from Stanford in the year 2000, but he stuck around on campus for a few extra years. He'd started building electric race cars with some other Stanford friends and really enjoyed the process. They would buy a normal car with an internal combustion engine and then install an electric powertrain and a battery pack. Each iteration would show small improvements, and more importantly, teach them a ton. A few years into building these vehicles, JB set a new world record using a converted electric Porsche 944. A few years later, JB moved to Los Angeles to work for AC Propulsion. The business was small, but they were one of the few companies working on custom-built electric cars, so it was a great fit. They had designed a two-seat electric sports car called the T0, and this thing was fast. It could do 0 to 60 in just 4.9 seconds, which is pretty slow by modern Tesla standards, but back then, it was fast enough to turn heads. There was a problem though. It had an extremely limited range. The original version of the T0 used a lead-acid battery pack and could only do around 100 miles of driving on a single charge. Fortunately, battery technology was improving rapidly at the turn of the millennium, and the latest generation of lithium-ion batteries had much higher storage capacities. When the AC Propulsion team changed from lead-acid to lithium-ion in 2003, their car's range increased to 300 miles, and the 0 to 60 time actually went down. The car could now hit 60 miles per hour in just 3.6 seconds.
And it was actually because of a technology shift that gave us a toehold to start the company. And it was a shift around the battery technology from lead acid to lithium ion. That fundamentally changed the type of product that you could build with an electric car.
JB had been building the perfect set of skills for years, so when he sat down for lunch with Elon in 2003, it was clearly the beginning of a great partnership. Elon was 31 years old back then, and he just made $165 million from PayPal, so he was ready to start writing some big checks in the green energy space. JB initially pitched Elon a plan to build a hydrogen-powered aircraft, but Elon wasn't a fan of the idea. It was a rocky start to the relationship, but JB saved the conversation by telling Elon about the T0. Elon already had a deep fascination with electric vehicles and instantly wanted to go for a ride. Even though AC Propulsion had done some great engineering work, the business plan wasn't as solid as it could have been. The T0 was just a proof of concept, and it didn't even have doors or windows. It clearly wasn't street legal, and even worse, it cost $220,000 to produce a single vehicle, so mass production was still a long way away. Elon and JB believed in the potential of the T0, but they just couldn't convince AC Propulsion to start scaling manufacturing. And this is why JB and Elon wound up working on Tesla and not AC Propulsion. It's all just a very interesting case of serendipity.
If we hadn't had lunch in 2003, Tesla wouldn't exist, basically.
Yeah, it's been quite an adventure of 16 years.
JB officially joined Tesla in 2004 as Chief Technology Officer. His salary was $95,000, but obviously the stock options he received wound up making that look like pennies. Every massively successful startup has plenty of stories like this, and it's a big reason why so many smart people take pay cuts and risk everything to work on bold new ideas. JB wound up getting a huge payday from Tesla, but this wasn't just luck. Without JB, who knows what would have happened to Tesla? And JB didn't join Tesla with financial gain in mind. Just like Elon, he had a great mission. JB was already thinking about climate change in the early 2000s and knew that electric cars could help significantly reduce emissions. On top of that, JB was a passionate engineer, and joining Tesla would allow him to work on the hardest engineering problems in the world. One of the first problems that Tesla ran into when building the original Roadster was finding a good supplier for batteries. Back in the mid-2000s, most lithium-ion battery manufacturers focused on consumer electronics, like iPods and laptops. They simply didn't have the experience or scale to support the demands of EV battery packs. It took Tesla years before they were able to ink a deal with Panasonic to reliably produce high-quality batteries.
Lithium-ion as a technology class was invented for consumer electronics. It was not invented for transportation. Today, and in the last maybe 1 or 2 years, have we seen that start to shift, where the manufacturing methods, the scale of operations, even the scale of R&D is starting to increase to the automotive level and to the energy storage level for the grid.
Supply chain issues weren't the only problem for Tesla in the early days, though. The Roadster also faced numerous design challenges. Tesla planned to use the Lotus Elise chassis to simplify the production process, but it actually wound up making things more complicated. In order to fit the massive battery pack inside of the vehicle, the Tesla engineers had to rebuild a large part of the original chassis. This was just the beginning of the Tesla Roadster's problems, though. In 2007, an internal audit showed that Tesla had been too optimistic about how much it would cost to build the Roadster. Instead of the $70,000 they had budgeted for, a single car would cost closer to $140,000. The plan was to sell each Roadster for $109,000, so Tesla would lose money on every car that they sold. The financial system was in turmoil at the time, so the team had to figure out a solution quickly. Fortunately, JB stepped up and worked with his engineering team to reduce the production cost to $80,000. It wasn't a huge profit margin, but it was enough to demonstrate the financial viability of the business and get Tesla through the IPO process in 2010. The Roadster project was easy compared to what was coming next, though. Everyone who bought a Roadster was an early adopter, and they knew full well that there might be issues. For Tesla's first mass market car, the Model S, the stakes would be much higher. JB led the team through a massive transformation as Tesla acquired a $42 million manufacturing plant in Fremont, set up a supercharger network, and then started working on the Gigafactory.
Pretty much, moved to Nevada in those days and camped out at the Gigafactory and did everything I possibly could do to make batteries possible and battery packs and motors and everything else. It was pretty crazy.
The Gigafactory allowed Tesla to bring battery cell production from Japan to the United States and finally guaranteed that they would have enough batteries to build new cars. It's impressive to see how successful this project has been. The factory now produces 37 gigawatt-hours worth of batteries every year, enough to make it the biggest battery factory in the entire world. But as JB was working on building the Gigafactory, he realized that solving the battery production problem would just create a new problem: battery recycling. Nearly 300,000 electric vehicles were sold in the United States last year, and this number is projected to grow to nearly 7 million per year by 2025. Factor in international markets, and you quickly get to a point where tens of millions of batteries will need to be decommissioned every single year. This can feel far away as you're driving around on a day-to-day basis, since most of the cars you see on the roads still use gasoline. But JB has seen exponential growth firsthand at Tesla, and he understands that there's really no time to waste. If we don't build enough battery recycling factories in time, we're going to be in a very tough situation. JB actually believes that the problem is so big, we need not one, but 4 different companies working on solutions. Now, obviously JB can't build all 4 companies, but he can certainly set an example in this new industry. This is why JB resigned from Tesla in 2019 to found Redwood Materials. The goal of the company is to build what's called a closed-loop battery manufacturing ecosystem. That's industry jargon for basically just recycling old batteries into new ones. And even though it sounds pretty simple, the technology required is extremely complex, and the business is very capital intensive. Investors clearly believe in the opportunity here, though. This past summer, JB raised $700 million at a $3.7 billion valuation from Goldman Sachs, Bill Gates, and Jeff Bezos. Not exactly a group of nobodies. And JB has already started putting this money to work. His first factory is up and running in Nevada and can process 60 tons of batteries every single day. That works out to the equivalent of just under 50,000 electric vehicle batteries per year, which is still a long way from the tens of millions of batteries we are expecting in the future. But it's a promising start. Even though Redwood is still a young company, JB and his team have already captured 50% of the lithium-ion battery recycling market and could do $90 million in revenue this year. JB's experience in the industry is clearly paying off already. He's been able to strike a deal with Ford to recycle their old battery packs, and partnered with an electric bus company named Proterra to manufacture new batteries. This two-sided closed-loop approach gives JB lots of flexibility when it comes to partnering with existing companies working on electric vehicles. Redwood can help recycle old batteries, which many companies don't have a plan for yet, or they can help make new batteries with the recycled materials. And even a company like Tesla can partner with Redwood. Even though Tesla's operation is pretty efficient, a small portion of the materials they use to make batteries at the Nevada Gigafactory end up going to waste. Redwood is able to recycle this waste and extract valuable materials to feed back into the Gigafactory manufacturing process. It's all about squeezing every possible efficiency out of supply chains. And when you're dealing with a massive industry, that has big implications. JB doesn't want to stop with just battery recycling though. There's another part of the EV battery supply chain under pressure right now. Car companies and battery manufacturers are constantly announcing massive plans to build out battery cell production capability. But making the batteries is just one part of the puzzle. The components that go into the cells, cathodes, anodes, electrolytes, and separators, also need to come from somewhere. Unlike Asia, which has a historically strong battery supply chain, the US lacks domestic manufacturing capability in this area. If we don't figure out how to make enough of these precursor materials, we could be faced with something similar to the chip shortage, where a lack of upstream components slows everything else down. Luckily, JB is already positioning Redwood to produce critical parts. A great example of this is his plan for a copper foil manufacturing plant. He recently bought 100 acres of land in Nevada to build a factory explicitly for this purpose. Now, a factory that only produces rolls of copper might sound boring, but this foil is actually really important because it's a key component needed to make the anode for the battery.
Copper can be even more silly. North America, is a big scrap market for copper. Wire, plumbing, all these things. We're a big generator of copper waste, yet we don't have much copper manufacturing. So we actually export copper scrap back to China, where it gets made into the same anode copper foil, then sent right back to North America to be made into batteries.
JB is also scouting locations to build a $1 billion cathode factory that should come online in 2025. Now, scaling this facility up will take time, but JB knows that entrepreneurship is a marathon, not a sprint. He's already looking toward a 2030 goal of supporting nearly 10 million electric vehicles per year. That type of long-term thinking has risks. If EV adoption slows, this facility could sit idle. But if current projections hold, Redwood will be in the perfect position. North America isn't the only market that JB is considering, though. Europe has many of the same supply chain issues when it comes to battery manufacturing, so he's planning on setting up a factory over there by 2023. The ultimate goal here is zero waste. Pull materials out of old batteries and use those materials to create new batteries. It's a remarkably simple model, but the engineering effort here is enormous. JB is pouring hundreds of millions of dollars into his research and development efforts, and they are already starting to see some results. Over 95% of the contents of a dead battery can now be successfully salvaged. The only problem here is that there actually might not be enough old batteries to recycle into new materials. JB has to scale Redwood at roughly the same rate as the overall electric vehicle industry, but demand for new batteries is much higher than the supply of used ones. So JB and his team are now working on recycling batteries from phones, cameras, and other consumer devices. Basically anything with a lithium-ion battery in it is fair game in JB's book.
It's something like 90% of the batteries that get sold to consumers, put in small devices, end up not recycled.
Redwood now has drop-off points with Best Buy to collect these old batteries, and the plan seems to be working, especially for cobalt. Consumer electronics have so much cobalt that Redwood might never need to worry about mining it ever again.
Sort of amazing, but only a few hundred iPhones, can provide enough cobalt to make a new Tesla battery pack.
JB's entire plan for Redwood revolves around reducing the environmental footprint of the battery supply chain. Manufacturing a new battery pack for an electric vehicle using only new materials creates over 5 tons of carbon emissions. But Redwood has already lowered that to just over 3 tons per battery pack and has no plans to stop there. JB envisions a future where no mining needs to occur to make batteries. Once the recycling ecosystem kicks into high gear, old batteries will provide everything needed to make new ones. It is worth pointing out here that when a battery wears down, the only thing that's actually destroyed inside the battery are the chemical connections between the different metals. All of the components are still inside of the cell, and with the right technology, they can be repurposed into new batteries. Redwood's battery components won't just be better for the environment though. They could also be cheaper. Back in 2010, the price of cathodes, anodes, and other cell materials made up only 30% of the cost of battery packs. The materials weren't the most expensive part of the batteries. The manufacturing process was. But engineers have since driven down production costs, so materials now account for nearly 60% of the price of the battery. JB has experience taking something expensive and figuring out how to reduce its cost without sacrificing quality. Every dollar that Redwood can save on battery components translates directly into 60 cents of savings. That's a big deal and will be really important for making electric vehicles competitive with traditional gas-powered cars. The story of JB Straubel is so important because it demonstrates the power of long-term thinking. Our world is changing extremely rapidly, and certain technologies are compounding exponentially. Things might seem slow at first, but after a few decades of compounding growth, suddenly everything is different. Being able to track these trends into the future and build a business that addresses an issue that is just on the horizon is an incredibly powerful skill, and one that every founder should pay attention to. If you like this video, don't forget to go enter your email at johncoogan.com, and please check out this recommended video. The YouTube algorithm thinks that you'll really like it.